Welcome back to the BigML tutorial series. In this video, we'll be talking about anomaly detectors, what they are, and how they can be used. First, we'll discuss anomaly detection, what it is, and the models BigML uses to detect anomalies. Next, we'll show you how to create an anomaly detector from a BigML dataset and how to interpret the resulting anomalies. After that, we'll show you how to filter out anomalies from your training dataset to generate a new anomaly-free dataset. Last, we'll show you how to generate a new dataset using this anomaly detector with anomaly scores for all input points. Let's begin by reviewing unsupervised learning. One way to categorize machine learning algorithms is by whether they are supervised or unsupervised. Supervised learning algorithms have a target variable or label that they are trying to predict. The job of the learning algorithm is to construct a model that can make this prediction accurately. In unsupervised learning, there is no label to predict. Instead, the goal of the algorithm is to find some interesting structure in the data and communicate that structure to users of the algorithm. While unsupervised algorithms don't make specific predictions, you can often apply the structure learned by the algorithm to new data and gain some insight about that data. A good example of unsupervised learning, and the one we'll be reviewing in this video, is anomaly detection. In every dataset, there are points that are anomalous, that is, outlier points that are unlike the other instances in the dataset. Being able to identify these instances has a number of different applications. For applications like credit card fraud detection and network intrusion detection, anomaly detection may take the place of supervised learning. In these cases, the positive instances, fraudulent or malicious activity, may not have any common characteristic except that they are unlike the vast, benign majority of activity. Anomaly detectors can capture this intuition in a way that unsupervised learning algorithms, which attempt to learn a decision function between the two classes, cannot. Another application is in the realm of predictive maintenance. Again, the vast benign majority of states of a machine or system indicate normal operation. Detecting instances that deviate significantly from this in any way may indicate some sort of failure mode. In addition, detecting and filtering out anomalous instances may assist with supervised learning. Outlier instances, such as the ones captured by anomaly detection, are often difficult to model, and the relationship between the input and objective fields may, by definition, be very different from the relationship in the vast majority of data points. Removing these points from the dataset makes learning a classifier less difficult for supervised learning algorithms and may lead to a more robust model. Finally, a trained anomaly detector can be used to assess the competence of a supervised model. By training an anomaly detector on the same dataset used to train the model, we can get a sense of how well an instance fits in this dataset, and thus how likely the model is to make a correct prediction about it. If a point has a high anomaly score, we may want to second-guess the model's prediction. The algorithm that BigML uses to detect anomalies is called an isolation forest. An isolation forest is exactly like an ensemble of decision trees, but with randomly chosen features and split values. Because outlier points, like x sub 0 in this figure, are by definition far away from the other points in the dataset, it will typically only take a few splits before these points are isolated in a node. On the other hand, typical points in the dataset, like x sub I in this figure, are surrounded by other points, and so it will take many random splits to isolate this instance in a node. We assign a high anomaly score to those points that take, on average over all of the trees in the forest, a low number of splits to be isolated in a node, and vice versa. Creating an anomaly detector in BigML can be done in one click just as with other BigML resources, using the Cloud Action icon in the Dataset view. Here, the dataset we're using is data from a real estate website, giving the features and sale prices of various houses in the Corvallis, Oregon area. We've filtered out some of the date fields, but the dataset is otherwise unmodified. Let's create an anomaly detector using this data. The resulting visualization shows you the top 10 anomalies in your data at the left, and the field values that make each instance anomalous at the right. For each instance on the left, the value near the orange bar is the anomaly score, a percentage showing how anomalous that instance is relative to other instances. Mousing over one of the anomalous instances on the left changes the right side display. The first two anomalies are unusually large properties. As you can see, the first has 8 parking spots, 4.5 bathrooms, and nearly 8,000 square feet of space, putting it well above average on all of those fields. The second is a more modest 2-bedroom house, but it sits on several dozen acres of land. Further down, anomalies number 7 and 8 are unremarkable properties, but both are located in the extreme southeast of the area from which these properties were taken. This shows that we can identify instances that are anomalous based on any field in the dataset using a single anomaly detector. Because anomaly detectors are so useful for data cleaning, you can create a new dataset without the detected anomalies with very little effort from the model view. Simply go to Select All near the top of the anomalies list, or select the anomalies you want to remove using the checkboxes in the list. Use the controls at the bottom to create a new dataset either without the selected anomalies or with only the selected anomalies. As mentioned previously, the trained anomaly detector doesn't make predictions in the supervised sense. It cannot predict the value for a field in your data. However, if you have a new dataset with the same fields, you can get the anomaly scores of all the points in the dataset using Batch Anomaly Score from the Cloud Action menu in the Resource view. As is the case with other batch resources, this will create a new dataset where a field is added to each instance, giving that instance's anomaly score. You can either download this dataset as a CSV file or view it as a BigML dataset, where the output dataset can be used to create other resources. In summary, we've learned in this video about anomaly detection, what it is, and when it might be useful. We then discussed how to create an anomaly detector in the BigML interface and how to interpret the resulting visualization. Finally, we showed how to get anomaly scores for an entire dataset of points using the Batch Anomaly Score action from the Cloud Action menu.